So in this video, we're going to look at the sum of a arithmetic progression and a geometric progression, or the sum of a AP and the sum of a GP. The sum of a arithmetic progression. So we call our arithmetic progression with an example. What was the example I used yesterday? 1, 2, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, dot dot dot. Yeah. So if I were to tell you, so if I want, so Tn is given by a plus n minus 1 t. So knowing the first term, knowing the common difference to get to whatever the n term is, let me try it for the 20th term. So T20 in the AP where I did in the video yesterday, I did it a bit different, but the math worked out to be the same, so doesn't matter. And T20 would be, well, 1 plus 19 by 1, which I expect to be 20 because it's increasing by 1. Now, if I were to ask you now, this is where the series part now, this is sequence. Remember, the series is a sum of a sequence. So if I were to ask you to find the sum from the first term to the 20th term, well, we could do that by the Gaussian method, which I described in a previous video, or we could use this formula, which states that the sum up to the n term is equals to n all over 2 into 2a plus n minus 1 by d, close brackets. So let's see this in action. So I'm going to do the sum of the first 50 terms. No, the sum of the first 100 terms to prove that we get the same answer from the Gaussian method video. The sum of the first 100 terms. So 100 over 2 by 2 by 1, which is just 2, and 99 by 1 is just 99. So you get the sum of the first 100 terms is 50 by, well, look at that, 101. And well, the answer is the same from the Gaussian method, where I was just having fun doing some tertiary stuff, but I kind of like show all the look different methods in maths are logically equivalent. What I mean by that, you could do different methods and get the same answers. So 50, 50, well, 5050, I don't know why I write it like that. And you could do this any amount of times, any amount of times. Now, let's erase some stuff. Freeform. This would be so satisfying to do. Like, oh. Right, so paint this over. So this is sum up to the end term, then whatever term you want to sum it at. Now, the next formula we have to look at is the one sec. Right, the next formula we have to look at is for the GP now. So the summa GP. Let's look at this following example. So no. Consider the GP 2, 4, 8, 16, 32, 64, dot dot dot. Now recall from yesterday that we had Tn is equals to a to the r, sorry, Tn is equals to T1 r to the n minus 1. So to get any term of the sequence, you just have to know the first term and the common ratio, and you could generate up to the 1000 term, and it will give you the value of the 1000 term by using this formula. Yesterday in my example, I wrote a specific form of the APs I was dealing with. This is generalized form. Now for the AP, that's two sums we're interested in. So the sum up to the first and terms, this is the following formula. It have two variations based on the value of the common ratio. So if the common ratio is greater than 1 or positive, we will get this formula. The sum there of the n terms is a. This is the first term into swapping T1 and E into r to the power n minus 1 all over r minus 1. And if r is less than 1, meaning the GP would exponentially decrease, like this one here is exponentially increasing. So the r is less than 1, we use this formula. S to the n is equals to a into 1 minus r to the n all over 1 minus r. Pay attention to these subtle differences. These two things swapped, and these two things in the bracket were swapped. Yeah. So, and the last thing is the sum of a GP to infinity, meaning you're adding all the terms in a GP. I know that kind of sound mind bendy, but it's possible. Just learn all the formulas, learn all the terms in the formulas, and just learn how to use the formulas at this level. And we would get E all over 1 minus R. So for this GP here, let me find the sum to infinity. So my E is 2. My R is 2. So 1 minus 2. So we get 2 over minus 1, which is minus 2. Now that answer seems weird, but math don't lie. And yeah, even though these things seem like the sequence seem to go to infinity, when you take the sum, which is the series, you will get a finite value. That property is called convergence of a series when it reaches a definitive value. Some series to reach a definitive value, you call that a divergent series.